I already uploaded a lecture note on the iClass today, but you don't download and don't use it so far. It needs to be adapted. So you can only download it. It's available. It will be available better in better form um, at a 12 o'clock. Okay, so don't download it. Don't use it. Oh. So we'll. Why is it so slow? What happened? So where were we last week? Where were we? I forgot to wipe this off. Okay, let me wipe it off and translate it into English. Okay. By the law of large number, which is very close to 1.5. 1.5 is the expectation of of x. Okay. 1.5 is the expectation of x. All right. So so when if we can calculate the expectation or the mean ex, then we can predict the results based on 8,000 results of 8,000 flipping. 8,000 times of flipping 3 coins. Okay. Hey, all the way to 8,000, which is labor intensive. Okay, and which is quick, which is uh, 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 which is time saving, very time saving. So you can hire 8,000 students to do the experiment for 8,000 times. Okay, each experiment flip 3 coins were flipped, and then you count the number of heads. Okay, and then sum them up and divide it by 8,000 to get the average number. Hey, this is the X bar. This is X bar, and this is mu, mean value. Okay, by the law of large number. Okay, in fact, by the law of large number, when n is large enough, we have the fake mean very close to the true mean. Okay, and where the true mean is true, but it is unavailable in practice. The fake mean is fake one, but it is available from the data, which is very close to the expectation of x, which is when n is large enough. Okay. Now let the 8,000 numbers of heads be x1, x2, and x. Oh, that's where we stopped last week, right? Okay. Now let us turn our attention to the variation of a random variable. So this is the location of concentration. Now it is time to learn to understand the variation of x of a random variable, or the variation of a set of data. And suppose that we hire 8,000 students to do the experiment. Okay, the experiment is to flip 3 coins, and you get the results. Okay, which is the number of heads. First student's number of heads. Second student's number of heads after he flipped the coin, 3 coins. And the 8,000th number of heads, 8,000 students, number of heads. Okay, and let us take for example, suppose that x1 is here, x2 is here, x3 is here. Okay, understand? And this is x1. How far is it from mu? How far is it away from mu? You just calculate x1 minus x bar. So there is no bar here. x1 minus mu. Okay, and the distance between mu and x2, it is x2 minus mu, right? And this distance is negative, so don't worry. Distance is always positive, okay? But here it is negative, but don't worry. Okay, this is the distance between x3 and mu. So what do you think? If the distance is large, then the distance, the distance, 8,000 distances are all very, very large. Then how will you say? then the data is clustered or sparse. What if, hey, if x1 is here, x2 is here, and x3 is here, then the distance will be very, very large. Okay, which means the data are very sparse, wild spread, randomly, chaos. Understand? Okay. But if the distance, all the 8,000 distance are very small, then the data will be very, very what? Very close to each other. Okay, very clustered. Understand? So let us use the distance to understand the variation of x1, x2 all the way to x 8,000. Okay? So let us sum the distance. Let us sum the distance. Hey, don't forget to square the distance. If you don't square it, the upper term will be trivially 0. Because negative part kick off the positive part. Understand? Hey, why do we have to square them? Because distance is always positive. And what happens if we don't square them? What happened? The distance will be trivially 0. Understand? Okay, so we have to square them. And now, if we square them, hey, x1, x2, all the way to x 8,000 is either 0, 0 hat, 1 hat, 2 hats, and 3 hats, right? There are only 4 possible outcomes: 0, 1, 2, 3. Okay? So, how many zeros are there? How many zeros are there in 8,000 experiment? How many 0 heads? Remember, if you do the experiment for 8,000 times, then 1,000 of them will end up 0 head. Roughly 3,000 of the 8,000 experiment end up with one head. Understand? And 3,000 of them end up with 2 heads, and 1,000 of them end up with what? With 3 heads. Okay? So if you square the distance and divide it by 8,000, then the result will be close to the sum of this product. Okay? So that's the distance. And very close to, okay? And that's the distance. And it can be a rewrite. The formula can be rewrite as this. Then it is 0 minus 1.5. Hey, mu is 1.5, right? Mu, last week, remember, it is very close. It is 1.5, 1.52, 1 minus 1.5, 2 minus 1.5, and 3 minus 1.5. Okay? So what is the result? 3 over 4. Hey, if you can do this, if you can calculate this, if you can do this part, then you don't have to hire 8,000 students to do the experiment. Okay? If you can do it, if you know how to calculate 3 over 4, then you can predict the results of 8,000 students. Understand? Understand what? what if you can calculate this? Yeah. What if I insist hiring 8,000 students and calculate the distance, sum of square distance? Very good. You should be a statistician. You know, very good. Yeah. If you can do this, then you don't have to hire 8,000 students to do the experiment and calculate the 8,000 square the distance. Don't bother. Understand? And if you can do this, you can predict the results of 8,000 students performed by 8,000 students. Of 8,000 experiments performed by 8,000 students. Understand? Okay. So okay. Here is the comment. Here is the interpretation of this number. If x1, x2, all the way to x8,000 are clustered, then the sum will be very small. Otherwise, it becomes large. Okay? So call this, hey, we call this sum of squared, call this sum of square the variance of x. So this is the variance of x. I don't know why the edge part, the marginal part is cut. I don't know why. It's not my fault. Okay. Okay. So that's the variance. Okay. So let us define the variance as the squared distance between possible value of x and the expected value of x. Hey, the left part, little x, is one of the possible value of x, and mu is the expectation or mean value of x. All right, times the probability that the random variable equal x. And in fact, it is the expectation of this form, of this, hey, you can regard this as a new random variable. You can call it y, capital Y, okay? Or you can write it as, hey, because mu is the expectation of x. Or simply, without bracket, simply, hey, square this, and take the expectation. Okay, this is hey, we invent this to write things, to write words, to write letters. Understand? But what do we invent this? Why do we calculate this? We calculate this to measure the variation or the dispersion of the random variable x. Okay? When the variance is big, then the variation of x is large. When the variance is small, the variation of x is small. Understand? Hey, what is x? What is x? X is a random variable. A random variable varies. It changes from time to time. Understand? From time to time, x1, x2, x1, x3, all the way to x8,000. It changes from time to time. It changes or it varies. So how much does it vary then? We need the measure of variation to see how much it varies, the random variable x, to see how random variable x varies. Okay, so this is the variation of x, And this is the central location of X. The location where X concentrate. Okay? So so mean and variance. Okay? And sometimes it is denoted by sigma square. Okay? It reads sigma. Okay? Understand? So here we finish mean and variance. Okay. Now it's time to proceed to the a very special, two very special distribution. The first special distribution is the binomial distribution, which is very usable and a very practical distribution in our real life. Understand? Real life, understand. If you are graduate and work for a few years, and your parents force you to participate in a blind dating, to look for your husband candidate, and for example, you do 5 such blind date, then you are doing 5 Bernoulli experiment. Bernoulli, Bernoulli experiment? Bernoulli experiment is an experiment with only 2 possible outcome: success and failure. Okay? 5. If you do 5 such experiment, blind date, what is the minimal value of a success? What is the smallest possible value of success? Huh? 0. And what is the maximum number of success? 5. So binomial distribution 5 means you do the Bernoulli experiment for 5 times independently. Understand? Okay. So binomial MP. For example, the flipping 3 coin experiment is a binomial experiment. Okay? Binomial what? 3, sorry. Which results in binomial 3, and the probability of success is 1/2. If the 3 coins, hey, if the 3 coins are all fair, honest coin, tail with probability 1/2, and head with probability 1/2, then we call this coin is honest coin. Okay, each outcome, head and tail, has probability 1/2. Okay, so for example, the flipping 3 coin experiment is a binomial experiment, which resulted in a 3 in the binomial 3 1/2 distribution. Sorry. Another example is the example of the examination. Suppose that suppose it's a hypothetical. Suppose that in the final exam, you will have in the final exam you will have 25 true and false question to answer. Understand? Then and the probability that you give the correct answer, you answer the question, the probability that you answer one question correctly is 1/2, and the probability that you fail to provide correct answer is also 1/2. Okay, true and false, because you pick up the answer at random. You flip the coin to pick up your answer. Understand? So that is also a Bernoulli experiment. Okay, and you will, in this case, you will have to do how many such experiment? 25, because there are 25 true and false question. All right. Hey, what is the name of experiment if you answer one question and pick up your answer at random, true and false? It is called Bernoulli. Yeah. And you do the Bernoulli experiment for 25 times. Then the experiment is called binomial. Okay. What is the first parameter of the binomial distribution? What is the first parameter of the binomial distribution? N, which is 25. And what is the second parameter of the distribution? 1/2. Understand? Because you pick up the answer by flipping the coin. If the coin is fair, is a fair one, is an honest one, then you will pick up the right answer, correct answer with probability 1/2. And also you will pick up the wrong answer with probability 1/2. So what is the distribution of such experiment? Binomial 25, the first parameter, and 1/2, the second parameter, the probability of success. And this is the number of Bernoulli trial you have done. Understand? So, and now what is X? Hey, raise your hand if you know the answer. I will give you the extra bonus. What is the meaning of X? Yep. Yeah, random variable. But your answer should be limited to, how do you say, corresponded to the scenario. Johnny answered 25 true and false question and pick up the answer at random. For example, flipping the coin. Yeah. So what is X? X has a meaning, right? What? No. Don't. Not the coin. Not the coin. Yeah. Yeah, you can say it in Chinese. Very good. You should be the statistician. Yeah. X is the number of questions Johnny answered correctly. Understand? You know why you cannot get the bonus. Okay, your name? What? Lin Yijun. Okay, where I will do it later. I have to write this first. Here, X, let X denote the number of questions he answer correctly. Okay, then X has the then X is distributed as a binomial distribution with the first parameter 25 and second parameter 1 over 2. All right. Second question, I will give you a second chance. Lin Yijun and you. Yeah. What if it is not a true and false question? What if it is a multiple choice question for answer? For how to say it, for answer, you know, for and one of them is correct. Multiple choice question. Four choices, but only one of them is correct. So what should be changed here? 1/4. What should be changed here? This is for a true and false question. But what if the scenario becomes a multiple choice question with 4 choices only, and in which only one of them is correct? Very good. Yeah, yeah. You also win a credit. And what is your name? Huh? Su Hanchun. Okay. Seat number 64. Seat number. Extra bonus. Yep, here. 64. Su Hanchun. Oh, Su Hansheng. Yep. 1. Lin Yijun. Seat number 80. 80. 18. Yep, 1 point. Very good. Yep. Okay. So note that when it comes to multiple choice question, multiple choice question with 4 choices and one of them is correct. Okay? is correct. Then X is distributed as binomial distribution with the first parameter 25 and second parameter 1 over 4. Understand? Understand? When it comes to the multiple choice question with 4 choices in which only one of them is correct, then X is also has also the binomial distribution with the first parameter 25 because he answered the question 25 times. 25, he has to answer 25 such question. But each time he will make a correct guess with only probability only 1 over 4 because they are now he faces 4 choices with only one of them is correct. Understand? You understand my point? Yep. What if there are 5 choices? 1 over 5. Good. But I'm not giving you extra bonus, you know? Yep. Okay. 10-minute break. The first line is the probability that Johnny answered 10 questions correctly. Exactly 10 answer. He 10 question. He answered correctly. So it is 25 choose 10. And 1 over 2 raised to the power 10. And 1 over 2 raised to the power 25. Understand? Okay. And the second part is the probability that he answer 10 to 15 questions correctly. Okay, the probability that Johnny answered 10 to 15 questions correctly. And the probability is 0.770477. And now, as you can see, hey, 25. If you wanted to calculate the probability, then you will have to calculate the factorial of 25. Factorial of 25 means 25 times 24. 24 times 23, all the way down to 2 and 1, which is very cumbersome, burdensome, computationally expensive. Okay, the computational burden is very, very big. And now I will teach you a method. Hey, and in the exam you have to calculate the probability, but your exam you will be taken online, right? Final. The exam is to be taken online. Is that okay? Hey, you online. You don't want to take the exam online? Huh? You want to take the exam here? Answer your question on paper? You don't, huh? Okay. Then you have to answer. You have to calculate the probability, and I'm now giving you the formula using Microsoft Excel. Microsoft Excel, okay? 10 to 15. So how to do it? I have to say sorry because the language of Microsoft Excel used by Microsoft Excel is Chinese. I have to say sorry, but it's not my fault because there is no English version of Microsoft Excel here. But I think the formula works also for your notebook or personal computer. Hey, here, just open a sheet, right? And type 0, 1, 2, 3, 4, all the way down to all the way up to 25 here. So it is 25 here. Hey, it is you have to pull down to 25 here, not here, not here. Hey, you see this is the 25th row, but it's only 24 because 0 is up here. Okay, so you have to drag it, pull down to the 26th row. Okay, and the first one here it is 1 over 2, so it is 0.25. Okay, right, and it is combination COMBIN, right? And what is the first parameter of binomial distribution? 25. Okay, and choose x times 1 over 2 to the power x here, and 1 minus 1 over 2, 1 minus 1 over 2. To the power what? To the power 25 minus x. 25 minus x. Okay? And x is in the address A1. Oh. What happened? Eh? What happened? Oh, here. A1 times, okay? And but I don't like the expression because, why? Because I will have to change the value of P later. So I also use address to get the number 0.25. Oh, no, not 0.20, this number. And this number. Yep. Yep, okay. And don't forget to use the dollar sign to lock it. Okay, to fix it. Yep. And hey, you see the little cross here? Go to the first cell. Okay, bottom right, and a double click. Hey, double click. Then you will finish the rest. Okay? And if you sum them up, you will have total probability all the way to 26, not 25, 26. The sum of the total probability will be 1. Anyone wanted to challenge me? I will give you extra bonus. Well, no, not extra bonus. I will just give you 100 if it is not 1. Okay? If I'm correct, all you have is your original score, no extra, no shift, you know. I think that it is a fair deal, right? It is 1. Okay? Now it is 25. And what if it is 5? 0.5. Yeah, it is also 1. And what if it is 0.3? The answer is also 1. Okay? Okay. Let me show. Okay, this. Yeah. Okay. Let me here screenshot. No Chinese. Here. Yep. Yep, here. Okay? And what is this? What is this? And what is the formula here? Here it is. What is this? This is, hey, C25, choose 2, and 0.3 to the x2, and 1 minus 0.3, 25 minus 2. Okay, and 0.3 is here. D1 is at D1. If you use dollar sign, oh sorry. If you use dollar sign, then D1, then the address D1 will be fixed for all B cell. If you don't use it, if you don't use the dollar sign, then when you drag down, then it will, the next cell will be D2, and then the third cell will be D3. Okay, so you have, if you don't want it to, if you wanted to fix it, then you have to use $, $2 to fix it. Okay, so will be fixed for all B cells. B cells is here. Okay. And in the exam, you have to calculate this probability. Okay. Okay. And the formula. Hey, combination. This is the combination, and the formula in Excel is COMBIN for short, and the full name is combination. Okay. Now, let me okay. Here. Let me show you how to plot this. Yeah, you highlight the B column and insert. Hey, bar chart here. Bar chart. All right. Bar chart. And it is 1, 2, 3, not 0, 1, 2. So you have to change it into oh no. Here. Here. Yep. You have to change it from A1 to A26. From A1 to A26. Okay. Wait. Not this one. Sorry. Yep. 9. Yep, here. Here. Yep. And it is 1, 2, 3, not 0, 1, 2. So I have to modify here, from here to all the way to 26. Oh yeah, here. Okay. Now it is 0, 1, 2. Here. Now it is 0, 1, 2. Okay. Yeah. It begins with 0 now. Yeah, 0, 1, 2. You see this? 0, 1, 2. Understand? Okay. And yep, here. Hey, let me show you the advantage of using a reference address here. That's the benefit of using the address. Yep, here. Now 0.3 is not used here. Here it is used D1. So anytime you change this, everything changes accordingly. Okay? Everything changes accordingly. So that's the benefit of using the address to denote to identify the number. You see this? 0.4 and 0.5. You see this? Hey! Attention, please. Look at the screen. And 0.75. You see that? Okay. So please go home and try it yourself. Okay? So let me show you 0.5. All right? Yeah. And now it is a true and false question. So it is now it has to be 0.5 here. And we wanted to what is the probability that Johnny will answer 10 to 15 questions correctly? So 10 from 10 to 6, 10 to 15, 10 to 15 here. Yeah, you just from 10 to 15 here, 10 to 15. Okay, this is the probability. Screenshot. Hey, yeah, screenshot. Yep, here. Sorry, no Chinese. Yeah, here. No Chinese. Yeah. Here. Okay. And paste. Yep, here. So it is the probability that copy, paste here, and paste. And so what is the probability? This is the probability of 10. He answered 10 exactly 10 questions correctly. Has probability what is the probability? The probability is 10 question 0.094166 here. Okay. Yep. Yep, that's the probability. Me? Duplicate. Oh, no, no, no. Yeah, this one. Okay. Yeah. This is not needed here. Not needed here. Yep, this one. Uh-oh. No Chinese. Distribution of yep. And I cover it. Distribution of binomial 25 1/2. Okay. If you don't want the space, I can help you to take it off. Take them off. If you don't want if you don't want the space between two numbers, I will help you to keep them up. Okay. No Chinese. Yep. Not this one. Sorry. Yep. If you don't want without space, okay. Here to customize, copy. Plot of without space between every two numbers. Okay. And what do you see? Hey, keep in mind. You first keep in mind because we will be back for this. Keep in mind that when P equal over 1 over 2, the distribution of binomial MP asymmetric. And bell-shaped. Okay. Is symmetric and bell-shaped. Okay. Keep in mind, we will be back for this. Okay. Next. And up. Okay. Now we turn our attention to the next. We turn our attention to the normal distribution. Okay. Here. Okay. Who is this? He was a German mathematician, Gauss, 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 maybe 200 or 300 years ago. Mm, his father wanted him to serve in the church in the religion, to work in the church, but he finally a teacher found his talent in mathematics, and persuaded his father to let him to study, to learn mathematics. Okay, he's a very successful mathematician, right? And he developed, he had discovered this curve, and this curve has a formula. I will give you the formula later. And the German government used the portrait of Gauss to celebrate his achievement. This is a very important contribution in statistics. Without this curve, without this distribution, without normal distribution, hey, then the volume, sorry, then the volume of this book will be only less than one half. Then you don't have to learn so much statistics. You only need to learn less than one half of them, because without the distribution, there is no so much, there will be no so much, so much formula in statistics. Okay, only one half without that curve. Okay, so you don't hate him, right? We have to celebrate his contribution to statistics. All right, this is German, but this is Deutschmark money, $10 Deutschmark. I want to buy one, but I don't know how. Maybe I can buy it from eBay. You know eBay or Amazon. I want to buy one. So what is the formula of that curve? Also known as Gaussian curve. All right. Okay. No Chinese. Normal distribution. Is given by okay. Is given by the formula f of x, okay, equal 1 over square root of 2 pi and sigma, and the Euler number. I will explain the Euler number raised to the power minus x minus mu square divided by 2 sigma square. Okay. There are also two parameters in the normal distribution. The first parameter is mu, and sigma the second. Okay. Yeah. No Chinese. It can be shown that. And reads mu. And it sounds like min. It reads mu. It sounds like mu sounds like min. So that is why the Greek letter mu is selected to denote the expectation of x, because it sounds like min. And this reads sigma. All right. One more slide. Here, E is defined by n goes to infinity, 1 minus 1 over n, and non-ending, no ending. Infinite decimal places, never ending. Okay, never ending. Never ending. Okay, is the Euler number. Euler number. Euler is a was a mathematician in Switzerland. Switzerland. Okay. E is used here to celebrate Euler contribution. In math, right? He raised the question. He first raised the question. What is the limit? He doesn't know the value of this limit. He doesn't know the limit of 1 over n to the power n. Hey, in his time, 1 plus 1 over n, and with n goes to infinity, is an open problem. No one knows the answer. Euler first raised the question, what is the limit of this number, of this formula, as n goes to infinity? He wrote a letter to his friend to ask the question. So we use E, which is the first letter of Euler, to celebrate his contribution in mathematics, and because he first raised the question, so he earned the credit. Maybe you can ask me a question. Okay, here. So hey, here. And the formula. Here, I will take you to plot the curve using Microsoft Excel. All right. Remember, keep in mind, there are two parameters. First parameter, mu, and second parameter, sigma square. And we will see what happens if this number changes and what happens if this number changes, okay? So let me use this. It's available in other classes, statistical classes, other classes. It's available. Hey, let me save it. Someone goes to goes to here to add the extra bonus. Someone? No? Okay. Yep, here. It's here. Yeah, this one. Oh, no. Not it. Not this one. Here. This one. Yeah. And announcement. Yeah, here. The normal plot. Okay. Yep. Yep, here. What is it? Hey, you see this? This is the normal distribution curve with the first parameter mu 0 and the second parameter sigma square 1. All right? And we will see what happens when the value of mu changes. All right? So let us first change the value of mu. Hey, attention. Look up. Attention. I'm going to change the value of mu, and you have to see what happened to the curve. All right? 0, I change 0, the mu value of mu from 0 to 1, to 1.5. Hey, to 1.5. It goes to the, okay? It goes to the right. And what if I make it into minus 0.5? Oh, no. Minus 0.5. Hey? No. 0.5. And here, minus 0.5. This is 1, sorry. This is 1. Yeah. And what about minus 1? Goes further to the left. And minus, yep. What? Mu equal to 4? 4? Then the x-axis, will be, you mean 4 or 5? Then I have to change, then I have to add some cells of this value. Yeah, I can 400, 4,000, any number. Yeah, okay. And to answer your question, 4. But the curve is not complete. Then I will have to drag it down to number 4. 4. Yeah. Oh. Yeah. 8. I think it is enough. and plot. No. Here. Yep, here. Hey? Hey. Yep. 4. Okay. Plot, scatter plot. Hey, use a scatter plot, okay? And this. That's 4. Okay. That's 4. And that is -4. -2. -2. -2. Okay? And -1. Okay? Hey, all we see is what? All we see is what? The curve change the location. It moves from left to right or from right to left without changing the shape. Does the shape change? No. When you change the value of mu, hey, when you change the value of mu, the curve, okay, shift, move from the right to left or from left to right without changing the shape. Okay? So let me give you more. Yep, here. We need more. Hey, drag up. Yep, yeah. And plot all of them. Scatter plot. Yep, this is better. This is better. Okay? When you change the value of mu -2 and -4. Okay? Understand? And +4. It just, okay. But let me make it. Yep, here. Maximum number 1.2. Right? Okay. -4. Yep. Right? So when you change the value of mu, the location of the curve changes accordingly. But what if, and that doesn't make it 0, okay? But what if we change the value of sigma? Okay? When you make it 0.5, hey, look at this. Look at this. It changes the shape. You see that? Hey, attention, look up. Look up for the changes. And 1.5, what about 1.5? It goes down. Okay? So, here. Yep, here. I'm giving you the Excel file. Yep. And mu determines what? Mu determine the location of the curve. And sigma determines the what? Hey, answer. Determines what? The what? The shape of the curve. All right? Go home and try it. All right? Yeah. You have to go home and try it, okay? Yep, here. And this one. And no more of this one. This one. Right? And also this one. The normal plot. Safe. Hey, go home, download it, and ignore the extension. Hey, parenthesis 1, parenthesis 2, forget it. Okay? It does not matter. So that's the lecture note for this week. And the roll call for the second hour. Roll call. Ready? You got only 5 to 6 seconds. Two seconds, 3 seconds, 4 seconds, 5, 6. Okay. Yeah. Yep. Okay. 几号？陈冠佑。Former part, later part, or the middle part? 17号。Yep. What? First hour? Yeah, first hour. You are too late. You were too late. You were too late. Later. Yeah. Anna. No. Too late. You? No. Huh? Sleep. Like letter. What? Sleep. Sleep? Yeah. Permission. So delete. Permission what? Like the print, the paper. You have for this first hour. What happened to the first hour? Delete. Because you are sick. But you look so well. Later. Yeah. What? Second hour? You know Sophia, the mathematician? No, she has to marry, to get married to travel abroad. That's the that's the law of her times. Yep, Sophia. Yep. What?
For the midterm homework, do we need to write the steps or can we just write the answer only? The midterm homework.
You can see the question, right? You write it in paper and submit to the teaching assistant.
We need to write the steps.
Yep. Yeah. The more detail the better.
Okay, thank you.
Yep. Yep. Okay. I give you.
So there's no way.
Okay. Okay. What is your name?
Seat number 64, 200.
Because you sit in the front, so I let you.
I'm late by like 3 minutes. Sir.
Okay. Got it.
Yes.
Fixed.